So let's discuss Norton's theorem. But before that, yun nga, before we give an example about Norton's theorem is let's contrast or let's compare yung Norton dito sa Thevenin's theorem natin. Anong pinagkaiba nila at ano yung kung saan sila magkaparehas. So now, ito yung if this is yung linear terminal natin, and this one also is the linear 2 terminal also in the circuitry natin dito. So, kung titingnan natin, same yung pagkuha natin ng Rn natin, R Norton natin sa R Thevenin natin, Rn tsaka RTh, R equal. Kasi parehas lang naman sila ng pagkuha. Kasi nga, ang ginagawa is, yung load natin, sa terminal load natin dyan, is tatanggalin at kukunin mo yung, if ito yung certain circuitry natin, if ganito siya, so yan, if dito tayo kukuha ng, ito yung load natin, kukuha tayo dito ng Rn, kukuha tayo dito ng Rn natin or RTh natin, ganun, kung ano yung way ng pagkuha natin ng RTh is ganun din yung way ng pagkuha natin ng Rn. Ganun lang siya. That the reason bakit Rn is equal to RTh. So, ganun lang siya. So, tatanggalin mo itong load na ito. Tapos, kukuha ka ng R equivalent dito na terminal. So, the reason kung bakit Rn is simply equal to RTh. Ganun lang siya. Now, how about IN? Pagkuha ng IN. So, sa pagkuha ng IN natin dito, guys, is mag-short circuit ka lang dyan. Kunin mo kung ano yung current na nagfo-flow dyan para mo makuha yung IN mo. Ganun lang siya. Pinagkaiba. Yung sa Thevenin natin is kukunin mo lang is kung ano yung open circuit voltage dyan. Kunin mo yung VOC mo dito, makukuha mo na yung VTH mo. Dito naman sa Norton's theorem is mag-short circuit ka lang dyan at kukunin mo kung ano yung current na nagfo-flow dyan. I-short circuit mo yan, look for the current flowing in that branch. So, ganun lang kasimple yung Norton natin. And also, ganito din siya. Ano yung connection nitong dalawang ito? If you can still remember yung source transformation natin, RTH at saka VTH. If you can still remember yung yun nga, source transformation natin. If we transform this one into parallel current into a certain resistor, so ganun siya. So we have IN at saka RN. So ganun lang siya or yun siya. So in this case, yun nga. We have ang IN natin nga is IN is equal to VTH over RTH. Kaya nagkaroon ng IN dito at saka yung RN mo is dyan, which is also equal to RTH. Ganun lang yung relationship ng Thevenin sa Norton. And you can see, kung doon sa theorem natin na Thevenin, you have VOC, which is equal to VTH. We have ISC is equal to IN ISC. Ayun nga, current Norton at saka short circuit current is equal. Ganon yung pinagkaiba nung sa Norton at saka Thevenin. To have an example, so now in this circuitry, let's have an example. In this circuitry, find the Norton equivalent of the circuit. So ito guys is, if you can't see it properly, ito is, ouch. So gawin natin tong, we have Kasi, yan. So, this is entering in this node and also this is positive. So now, to have the Rn, syempre, tulad ng pagkuha natin doon, is dito na terminal, kunin natin yung Rn natin dito. Just like what we are doing in the Thevenin theorem, patayin yung mga, i-off yung mga sources, we have open circuit ito, short circuit ito. To make this 0 and also to make this voltage source is 0, we have 4 ohms, we have 8 ohms, 8 ohms din dito, and also we have 5 ohms dito, and kunin natin yung Rn natin dito. Now, simply, ang mangyari dyan is we have 8 in series with 4 and also in series in 8, and the series combination is in parallel with 5. So first, we have 8 plus 8, we have 16 plus 4, we have 20 ohms. 20 ohms in parallel with 5. So, ang Rn natin dito is, Rn is equal to, Rn is, we have 20 times 5 over 20 plus 5. We have ilan to? 100 over 25. So, ang Rn natin dito is 4. Diba? We have 4 ohms. We have Rn natin is 4. And now, for ang In natin, the ISC natin, or ang IN natin, ang IN natin, ang IN natin now is, syempre, short circuit ito. Short circuit to ha. Short circuit natin to, and we solve yung ISC dito. So, kung mapapansin nyo, this is short circuit in parallel with this. Syempre, kung if I were the current, I'll choose this one. Neglecting this one, kasi nga more resistive ito kaysa dito. Kasi ang resistance natin dito is equal to 0. So, ito is neglected. So, ito is mawawala ito sa circuitry. So, we will have a new circuitry of this one. Balik yung mga sources natin. Ibabalik natin. We have 4 ohms and also we have 8 ohms. Now, we have 18 dito. 8 ohms. And also, we have, yan. So, we have ito, open circuit ito. Ay, short circuit ito. So, makukuha natin yung ISC dito or yung IN natin. Now, to solve this one, we can easily solve this. How? So, pwede natin sabihin na loop analysis or mesh. So, we have loop 1 dito, I1, and also I2. So, yun, we have loop I1, loop I2. So, as you can see, itong I2 na to is equal to I1, di ba? So, we have I1 natin is simply equal to 2 ampere. So, at loop I2, so, ang loop I2 natin this time is we have, di ba? At loop I2, we have 4 times I2 minus I1 plus 8 I2 plus 8 I2 minus 12, di ba? Minus 12, which is equal to 0. Collecting like terms, we have 4, 16, we have 20, di ba? We have 20, oops. We have, what's this? We have 20 dito, 20 I2 minus 4 I1 is equal to 12. Tinranspose ko dito. And also, noting that yung I1 natin is 2 ampere, di ba? So, ngayon, makuha natin is yung value ng I2 natin. We erase this one here. So, we have, di ba, we have 20 I2 minus 4I1 is equal to 12. And ang I1 natin is 2 ampere. Now we have 20 I2 minus 4 times 2 ampere is 12. We have 20 is equal to 12 plus 8. Transpose ko. I2 ito. We have 20 is equal 20 I2 is equal to 20, right? So ang I2 natin, this is 1 ampere. Diba? We have divide both side by 20. Now we have 1 ampere. And noting that, kung titignan natin yung loop, if this is I2 natin, they are the same direction with the ISC natin and this I2 natin. So, therefore, ang ISC natin or ang IN natin is simply equal to I2, which is 1 ampere. So, now we have that. So, we have to summary, as a summary, we have Rn natin is equal to 4 ohms and we have In natin na 1 ampere. So, this one, so, wait lang. So, yun na. We have ganito. In natin, tapos Rn natin, tapos dito yung terminal natin. So, what if sabihin natin na in this load, in this terminal, naglagay tayo ng certain load. Kung gusto mong kunin yung, what if gusto mong kunin yung kuan dito? What if you are tasked to solve for the voltage or yung current na nag-flow dito sa RL na to? So, simply, what if 6 ohms ito? 6 ohms yung nag-flow dyan. Ngayon, you can easily use current division. Why? Kasi nga, we have ang IL ko is simply equal to Rn multiplied by In over Rn plus RL. And ang current na nag-flow kay IL mo is simply equal to 4 ohms mo multiplied by 1 ampere na In mo 4 plus 6. Now we have 4 over 10 or 0.4 ampere. So, ganun siya. Yan. So, to solve for voltage naman is simply VIR. So, we have for VL, we simply have 6 times 0.4. So, what's the 4% of 40% of 6 ohms? So, we have 2.4 volts. So, ito yung voltage ng certain na load if ever maglagay ka dito ng certain na load.